Let us now consider Unit 8 of Module 3, and that is vertical stress at any point below a uniformly loaded circular area. The difference between Unit 7 and Unit 8, both are uniformly loaded circular area, but it differs on the point of consideration. For Unit 7, the location is always at the center below the circular area. And for Unit 8, it is at any point below the circular area. Let's take a look at this figure. It says that the point of consideration is any point below the circular area. So it can be within the circular area or even outside the circular area, as long as it is not at the center. So if it is at the center, we will be using method that was discussed in Unit 7. Unlike the other loads that we have considered in the previous, we always use two methods, that is by the use of equation and by the use of a table. For this case, we will only be using the method of using a table. So the vertical increase at point A in the soil mass is given to be Q multiplied by the quantity A prime plus B prime, where A prime and B prime are functions of Z all over R and R all over R. Small r all over big R. Z is the depth from the soil surface up to our point of consideration. Capital R is the radius of the circular area. And then the small r is the shortest distance from the center of the circle up to the point of consideration. But take note that this is measured on the surface. It is measured on the surface. We will be using two tables in this topic. One is table 3.7, which is the variation of A prime. In short, for the value of A prime, we will be using table 3.7. And for the value of B prime, we will be using 3.8. So be sure that you will not be confused on which table are you going to use. And then also with the value of small r and capital R, take note also so that you will not be confused. Let's go over the procedure. First is we determine the ratio between the depth and the radius, and then the shortest distance on the surface from the center of the circle up to the point of consideration, or the small r divided by the capital R, which is the radius of the circle. Next, we refer to table 3.7 to identify the value of A prime. We refer to table 3.8 to identify the value of B prime. And upon identifying the value of A prime and B prime, we now substitute it to the equation. Vertical stress increase is equal to the unit load times the quantity A prime plus B prime. Let us now take a look at the sample problem. Refer to figure 3.55, this one. A flexible circular area of radius 6 meter is uniformly loaded by Q is equal to 450 kilonewton per meter squared. Determine the increase in vertical stress at point A. This is the plan view, and then this is the cross-sectional view. We have here a circular area with a radius of 6 meter, and the load is 450 kilonewton per meter squared. We are to determine the vertical stress increase at point A, and point A has a depth of 6 meters. So given the radius of the circle is 6 meters, the unit load is 450 kilonewton per meter squared. The depth is 6 meters. And at the same time, although it was not stated in the problem, we can see it from the figure that the value of small r is also 6 meters. So in this problem, the radius is also equal to the value of small r. Let's now go over with the solution. First, we are to determine the value of z all over capital R and the small r divided by capital R. So z all over r, that is 6 meters, and 6 meters is equal to 1. small r over capital R, that is 6 meters also divided by 6 meters, and the value is also 1. Next, we refer to table 3.7 to identify the value of A prime. Always check the label of the table 3.7, or you may not memorize the table number but the caption variation of A prime. So A prime. Our value for Z all over R is 1, and then our value for R all over R is also 1. Therefore, the value of A prime is 0.17868 from the table. Next, we refer to table 3.8 to identify the value of B prime. Again, check the title of the table, variation of B prime, because both tables look alike. Going back, our value for Z all over R is 1, and then for small r over capital R is also 1. Therefore, our value of B prime from the table is 0.15355. So since we already have the value of A prime and B prime, we can now substitute to the equation. Our Q is given to be 450 kilonewton per meter squared multiplied by the value of A prime and the value of B prime, which we were able to get it from the table. Vertical stress increase is 149.5035 kilopascal. That is now our answer.